Welcome back, teachers. I am Aubrey from Aubrey Teaches with another video for you today. If you notice and you've been following along, I am in a different spot. I just moved to a better location in my apartment. Also, if you hear some kind of noise, it's feet walking by, and it's my dog Luna, and she may make an appearance right here in the video too, but she will be walking back and forth, so that's who you're hearing. Today I want to talk to you about a really important topic, and that is misconceptions that we have as math educators. And I'm starting kind of a series based on a book, and I want to share this book with you. It is from the NCTM, the National Council for Teachers of Mathematics, which is a really, really great organization that you should look into if you teach math. And it is called Principles to Actions. It's not a very long book, and it's really, really chock full of great information. So you should look into this if you do anything related to teaching math with students. And in it, it talks about the 8 principles of quality mathematics instruction and the actions that you can take to start using those principles in your daily teaching. So I will talk about the 8 principles, but today I wanted to talk about this one page that talks about the misconceptions and beliefs that we have as math educators typically. And these misconceptions do not just come to us because we want to have misconceptions. These misconceptions came to us because this was a lot of the way we were taught growing up, or a lot of what we've experienced. Even some of the ways we were taught was best practice, and it's just built these misconceptions. And I just wanted to talk for a little bit today about what those are and why they are very unproductive. So this is, if you have the book, on page 11, we're going to kind of go through them and just talk for a little bit about what this kind of looks like and plays out like. So the first unproductive misconception is that math learning should focus on practicing procedures and memorizing basic number combinations. So a lot of things will have the same kind of vein, this idea that math is a content that we pass on to students, which is simply not true. At the end of this video, I'm going to talk a little bit about how you can get into the natural number training that I am offering. And I talk a lot in the natural number training about how human brains are actually really ready to do math, how the brain research has shown that we have a very logical, reasoning, pattern-making brain that is ready to do math and is not ready to follow a lot of isolated procedures. So if you want more on that, you can get into the training. But right now I'm just going to talk a little bit about how, you know, as a teacher, it's really, really hard to get your kids to retain a bunch of isolated information. They're doing that a lot in the way that we teach them most everything, and it's really hard. You know that, you've probably experienced that. It's really hard for us as adults to retain a lot of isolated information, a lot of isolated facts, a lot of isolated procedures and formulas and things like that. So when you look at math as a content area that I know and I need to pass on to my kids, it's going to be a struggle. What we need to do is start shifting away from math as a content area to pass on into a skill. So math is actually a skill that we use. It's something we use to understand patterns in the world around us. Now, there is some parts of math that we have created to make it make more sense. For example, the number system. We made this base 10 number system, and these are what the numbers look like, and these are what we call them, and those have to be taught to students. Or like vocabulary. So a student needs to be told whenever they have discovered, oh, I can make a shape out of small square tiles. Oh, the whole of that shape that you discovered is called area. We can call that area. Things like that. We have put vocabulary and systems into math, but the basis of math and what it is actually a skill. It's a lot of problem solving, reasoning, thinking, collaborating, discussing skills. A lot of these things. Now, students do access content like addition, subtraction, multiplication, area, perimeter, content, but they can access that through the skills of mathematics. So here's an example. A lot of times we just teach the content. We say we're teaching area today. We're going to show our students what area is. We're going to tell them this is called area, and they're going to practice area, right? We're thinking of math as a content. I know what area is, and I'm going to show my students what area is. But what students can do that will actually be doing math is a higher level cognitive demand problem. I talk about this a lot on my blog. I also have talked about this in the video. High cognitive demand problem is a part of every lesson that I do because it's how students use their math skills and access content. And the teacher is there as a facilitator to help that happen, not as a person to pass on content. So instead of teaching your students, this is what area looks like, this is what we call it, now you go practice it, you can start with a high cognitive demand problem. Present that to kids. They can use their skills of math, which are problem solving, reasoning, using their logical pattern brain, communicating, collaborating, representing, which means you should always have manipulatives on hand that they can use to help them make sense of the problem. We have manipulatives always and dry erase boards and markers always, so they can draw if that's what would help them. And then they can access content through that. So for example, I used an example one time about saying that Nate's mom saw ants in her house, and she saw between 35 and 45, I don't remember exactly, legs. How many ants could there have been? You can see how students would be excited more about that problem than a list of problems of multiplication, right? But they're still doing a ton of multiplication in that problem, and they can go off in groups and they can grapple with that. They can use manipulatives, they can use the dry erase boards and markers, whatever. They'd be using all of their math skills, and when they come back, now they're ready to put that with content. So now you can show them, when you guys were making equal groups of things, we have a name for that, it's called multiplication, something like that. So the misbelief is that mathematics learning should be practicing procedures and memorizing things. So I should show you and you should practice it is a very hard misconception, because that's a lot of how we think. We have to stop thinking of math as a content to pass on and more as a skill to help our students get better at. Okay, the next one is one near and dear to my heart. I have a blog post on this, and this is kind of my soapbox, if you will, a little bit. But this is that students need to only learn and use a standard algorithm to solve algebraic problems. This goes hand in hand. I told you a lot of these go together. But if we are thinking of math as a content, then we are thinking of, I know the best way to do this problem of addition. We'll use that as an example, and now I'm going to show it to my students. Instead of helping my students discover the skill of joining and separating numbers. So we have taught them the number system, and their brain is ready to join and separate numbers, but we just teach them this one standard algorithm, whatever that looks like, because it's actually not the same in every country. It doesn't matter. It's anything that works the way it works every way. It will always give you the right solution if you do it right every time. That can be anything. And in my blog post, I talk about how an algorithm can be anything, and we need to be careful that we're not making really good strategies just into algorithms, because if we present it to kids as the way that I know and now you do, then we're putting them in this box of math as a content again. And I think this is the day in math classrooms that students start to carry that misconception with them. I think the day we start presenting algorithms to students is when they start to think, oh, okay, I know what math is. Math is something my teacher can do, and she's going to teach me how to do it. Whereas what really is the truth is students are ready to do math too. They're ready to do math when they come to you, and you need to help them with that skill that they are already ready for. Instead of them thinking, oh, math is something I listen to and I learn, they can view math as something that they can do. And that is making it just more engaging from day one. Okay, this one is also really important. Students can learn to apply math only after they have mastered the basics. So we hear this a lot with like back to basics, people saying we need to get back to basics and things like that. This also plays out a lot in, oh, I do math projects and I do these math things, but only when students finish their work. So it's for my early finishers, or it's for my kids that are really fast, or it's for my advanced math kids. So the only kids that are accessing the actual doing math are a small portion of your classroom, and that is building a math room that is unequitable. It's not fair, and it's not equitable for every student is not accessing real math that their brain is ready for. And this is a misconception, and I've seen this firsthand because I have students in my third grade classroom that come and are quote unquote low in math because they struggle to remember all this isolated information, and by the end of the first semester, after a lot of number sense games and activities, high cognitive problems and engagement, they rise so much. And they weren't hindered because I didn't have to put them what we call back to basics, which when we say that, we're really thinking they need to know their facts, right? They need to know how to do the math in the way that I know works, which again, we're thinking of math as a content, and that's not it. Math is really a skill, and all students that have a developmentally healthy brain are ready for that. And if they are not ready for the high-level math tasks that you're giving them, then the back to basics might mean going back and giving them high-level math on the level they need. Not dumbing it down and giving them just very not math formulas and things to do, but still giving them high cognitive math, maybe in some of the areas that they have holes in. So just a lot of shifting what we think about math. And then the next one is similar to the first one, so I'm not going to talk a lot, but the role of the teacher is to tell students exactly what definitions, formulas, and rules to use. And this happens a lot when people are trying to shift to high cognitive demand problems. They're still in that mode. So when students start and they come to a roadblock, they get to a bump, the teacher goes, I can just tell them how to do it, right? They're not getting it, I'll just tell them. If you guys do this, it will work, and it's really hard not to do that. And especially if you've had students very used to that, it's hard not to do that because they give up faster and they don't feel like they have the skills, even though they really do, and you have to really help them. So your role is not to show them and tell them. Your role is to help them. And that is what one of the mathematical practices is, posing purposeful questions. It can all start with just asking, where do you think we should start? Let's try it. How did you get that? Show me how you did that. These type of questions are just where you can start. And you can start becoming a really good questioner just by starting there. And not just when kids get something wrong. Start questioning students all the time. If you go to a student, they have a right answer, question them. Show me how you did that. How did you get that? Could you draw that out for me? Can you help me explain that to me? Wrong or right, because we don't want them to set them up to think, oh, my teacher only questions me when I'm wrong. How many times does this happen? This happens to me all the time. I go up to a student who's doing something with math, and I say, oh, explain that to me, and they just erase. Like, they just start erasing, right? Because in their mind, math is a content. My teacher knows it. I don't. She's questioning me. I got it wrong. She's going to show me how to do it. So we've got to get out of that mindset. And our role is to facilitate, and that's all asking good questions, knowing your kids, knowing, which groups to put your kids in, who they can work with, and who is going to share more and who's going to be less inclined to share, all of those good things. That is a lot of making a really purposeful math teacher. Okay, the role of the student is to memorize information presented and then use it to solve problems on homework, quizzes, and tests. Again, math is not content to practice, practice, practice. Math is a skill to practice, practice, practice. So it might not look like a quiz. Now, you can practice math skills through a quiz, but it is not the only way. They can practice it in a lot of different ways, and it can look very different than what we're used to. Okay, and finally, an effective teacher makes math easy for students by guiding them step by step through problem solving to make sure they're never frustrated or confused. Oh, and this one goes with the practice that we need to support productive struggle. Because we tell our kids this all the time, I feel like, with growth mindset being such a big thing, we tell our kids, you learn when things are hard, right? But we save them so much because it's hard on us. It's hard for us to see them struggle, but there's a difference between a true struggle and a productive struggle. And students need to have a little bit of productive struggle because guess what? Through productive struggle, they're building those skills of problem solving, reasoning, collaborating, communicating, those things that we want them to be able to do, not just in math, but in life, right? Wouldn't it be nice to have people that are awesome at problem solving, communicating, collaborating, reasoning, right? Wouldn't that be nice? So we need to help students think of those as their skills. Their skills isn't, I am really good at adding, subtracting, multiplying, finding area, doing quadratic formula, XYZ. I am really good at solving problems. I'm really good at explaining my reasoning. I am really good at communicating to others. I am really good at representing my thinking with manipulatives or drawing, whatever. Those are the skills that we want students to do. So those are some of the misconceptions that we have prevalent in our society and with math teachers even, that we're hoping to overcome. And the number one thing is to move away from thinking of math as a content to math as more of a skill. And if we can get that, our minds around that, then we are ready to start growing in our practice as math teachers. So I hope that makes sense. And if you want to learn more, the book again is Principles to Actions, and you should try to look into the NCTM website. They have a lot of great stuff. I am at aubreyteaches.com if you want to look into the blog posts that I have about high cognitive demand problems and problem solving. And as always, if you have any questions, you can email me at aubreyteaches@gmail.com. Remember, math is natural. Happy teaching.